We ready?
We're squatting.
Oh, look at all the comments.
Oh my god, so many comments already.
All right, cool. Let's get started.
Hi, friends. Hi, I'm Yassine, part of the autonomy team, research team.
Oh yeah, hello, I'm Harold. I'm also part of the research team. Yeah, I don't know, Yassine's got some cool stuff to show you today. And we're going to talk about all of our latest experiments, all the new model architecture we're working on. Yassine's been working pretty hard and is going to give you a cool overview of all the new exciting stuff.
We have a lot of comments. Maybe we should just catch up on the state of things here.
Alright, let's see.
There's like 400 people in here right now.
Wow.
This model's tranquility-wise, so we'll talk about that while we're driving. This will be a live drive based off of training. That was all simulated. Yeah, we trained in a simulator. This first software feature doesn't work on the Comma. Why wouldn't it? No, it works on the Comma 3. We're going to Taco Bell again. So this won't be a Taco Bell drive.
Taco Bell was more about selling you what is possible. Now we're focused on actually shipping things to you that work for you every day, that are reliable.
Love the software, but I don't think anybody wants regressions. Yeah, we don't want regressions either.
So we drive with openpilot every day. We're just as annoyed about regressions as everyone else is.
There's a sale right now. Guys, we haven't even built half the comma 3Xs we plan to build. I've been saying this for months. This is still true. We're buying lots of parts, lots of A45s. 1.0 win. We'll be talking about that soon, actually. First introduced the guy with the yellow hoodie. Billy's right over there.
Many Billy's here.
Yeah.
Billy has arms, he's been working out.
Oh, behind the mic is bad audio. Okay.
Well, you should just speak louder.
I should speak louder. Okay. Volume is way too low. I think
is the volume low?
No, it's okay, I think.
How's the volume when I speak?
Even me,
Say again?
I'm okay too.
Yeah, you're okay too. It's better in the front of the mic, but that's fine.
You can turn
Okay.
it sideways.
Okay, I think we're caught up on the comments.
Yeah.
Let's give them a preview of how it all works.
So we wanted to talk about the challenges, the hiring challenges a little bit before we start talking about MLSM. We just finished the comma VQ compression challenge. For people who are not familiar with what it was basically
You can go to comma.ai/leaderboard for this.
the goal of the challenge was to losslessly compress video tokens
This isn't a Dolby experience.
that come from comma VQ. And the idea was to essentially start with something that's already lossy, the result of a lossy compression algorithm that gave us already a good frame by frame compression, but then we wanted to add additional compression on the frame to frame compression, and we had some pretty cool results. A lot of people beat our baseline, which was I guess pretty easy to beat, but nonetheless pretty nice. So we had two kind of solutions. We have solutions that use standard compression algorithms like ZPack and such, and then the winner, Panayotis. So shout out to Panayotis, who used a GPT. So pretty cool solution using GPT together with arithmetic coding, and then reached a 2.6 compression ratio. Many other people actually attempted using a model, some kind of predictive model to compress the data, but only Panayotis was able to do it successfully. So shout out to him and congratulations for winning the challenge.
Yeah, it's really cool too that in this case the coolest solution also won. You know, sometimes there are cool solutions that suck. It's really cool to see like the list of simple compression, better standard compression, and then complex compression be also the ranking of quality. That's pretty awesome.
Yeah, the solution is really cool. We were expecting something like this to be the winning solution, and that's what we got. So we're gonna keep cycling between these challenges and updating them. And
So let's say next challenge launches Tuesday next week?
Yeah, sometime next week. We can figure out when. It's going to be another iteration of the controls challenge, but we've just learned a lot over time. We're making it a bit more cool. Both of these challenges, the compression challenge and the controls challenge, are very much in line with the type of work that is necessary to make openpilot good. The compression challenge trains GPTs. That's at the core of now current openpilot performance. And the controls challenge is a bit more long term, but we need solutions like RL, on-device learning, potentially gradient-free optimization to get really good controls on all the cars. We can't hand-tune cars forever. Obviously humans don't do that when they learn to drive a new car, and we need that to work with machines as well. And the controls challenge kind of tests that ability. But currently research just isn't in a place yet. Not just us, but I mean just the state of research where this stuff is easy. But so that's kind of a more long-term thing.
So they're asking what a good score for the controls challenge is.
I mean, look at the leaderboard. If you get better than the number 1 score, then it's a good score.
Quantizer 66. By the way, Quantizer is...
He's an intern here.
Yes.
Yes, that's Jimmy. He's here now. He's found important bugs in the controls challenge and completely blown out of the water all the other scores. I think I managed to get a score below 60, knowing my knowledge of how the challenge was created, so it's a little bit cheating. So we know that's possible. So I think probably the best possible score might be around 50 or slightly lower. But yeah, this is a very the gradient of quality on this challenge is really cool. Like it's always possible to do better, and the solutions become harder and harder.
Yeah, but it's really fun, you guys. These challenges are really nice. They're really in line with what you would with the job that you would do here, and I mean you learn a bunch of things doing them.
I mean, this is most of our hiring process too. You submit a good challenge, you do a couple phone calls, and that's most of the process. Super straightforward. We hired Jimmy, I think, like less than a week after he submitted his challenge.
Yeah.
Yep.
And if you look at our old challenge, Casper's not here today, but Casper's record on the calibration challenge blew everything else out of the water. He had a very sophisticated solution, and it wasn't luck, it wasn't a trick, he didn't cheat. He genuinely just had a solution that was that much better than everyone else's. And he got hired. He does cool stuff here now too.
Somebody's asking for the source code for the winners. So that's up to them. We'll link it if it exists after the challenge is over. So the method for these guys was redacted until the challenge ended yesterday. So you can click on their GitHub, and then you can see if they publish the source. But we will not publish the source ourselves.
Yeah, I mean, we've kind of changed our opinion on this. In the beginning, I was kind of pressuring people to not, publicize their solutions. But over time, I think, if you copy someone else's solution, obviously that's cheating. That's going to come out. If you get away with it, we'll notice in the interview that you didn't come up with this yourself. Like, that's obviously not the point. So a lot of these people actually have been developing in the open. It hasn't really been a problem. Another big change that's been to our challenges. In the past, we had, private validation sets. We're trying to move away from that. It's really hard to make challenges where when you're developing on the challenge, if you get a result, that result will translate to how we evaluate it. The control challenges like that, I think those are the coolest kind of challenges, because when you do well, you did well. You don't have to wait for secret evaluation. So we're going to try to do that as much as possible in the future as well. I think it's just the coolest type of challenge. It's also just the hardest to make, but as possible, we'll do that.
Let's quickly show for the other challenges.
So we have the compression challenge, which is just done. Controls challenge, which will come back soon.
We're looking for a designer, so we got a design challenge. Hiring for the hardware team. We've got a hardware challenge that has some hardware elements, some software elements, and then some older software challenges.
Yeah, if you go back to the hardware challenge, you'll see a familiar name, which is Jimmy again. Jimmy is such a fan of challenges. He managed to do well on 2 completely different challenges.
So all 3 of these people on this list are people we've given offers to. So this makes it super clear what the bar to work here is. This is our best definition of people we're looking to hire. So if you can do the challenge as well, you're probably a good fit.
So I see a question in the chat saying that this is a complex hiring challenge. I 100% disagree. This is one of the simplest hiring process. This is one of the simplest hiring processes I've seen. It's really clear. If you go to comma.ai, / jobs, there's nothing hidden from you. The process is super simple. 3 bullet points, 3 steps, and everything is transparent. So you can see this is not difficult at all. Compare this to multiple days and multiple rounds of lead code, of whiteboard interviews, of HR screening, all this stuff. It's not complex. This is very straightforward, and in my opinion, this is a really fair hiring process.
Yeah, I mean, obviously you don't get paid for the challenges if you don't win. You should be having fun doing them. If you don't like the challenges, you're probably not going to have a good time here either. If you really want to get paid, you can do the bounties. Doing bounties is very similar to doing the challenges in terms of getting hired here, and you do get paid for those. I think this is a super fair process. And yeah, in general, the turnaround time is a matter of 1, max 2 weeks. If nothing crazy is going on at Comma, we generally schedule an interview a couple days after we get a good challenge, and then move over to either reject or accept within a week after that.
So you're saying if we do the challenge, we don't have to do any technical interviews. So I think that's the wrong way to think about that. It's not about like cheating the process.
Again, everything is if this question is asked, you have to read comma.ai's job. Everything is laid down. Number 1 is the challenge or the bounty. Number 2 is a phone call, which will be technical. Number 3 is a paid micro internship, or internship if you want to apply for an internship. So very straightforward, and in my opinion, very fair.
Yes, but yes, you cannot get out of a technical interview. If you manage to do well on a challenge and terribly on a technical interview, that is also, I think, people see the technical interviews too often. People are worried that they do poorly on an interview because of various circumstances. Generally, a good interviewer can see straight through that. If you have technical ability, whether you're having a bad day, whether you're tired, it will be obvious in the technical interview. Doesn't matter if you woke up late or any of those things. You can't, you don't just suddenly forget all of the technical things you knew a week before.
Yeah, and you're not talking to like a recruiter who has like a checklist. You're talking to me or Harold. So.
Yeah, nobody's asking you what your weaknesses are.
Yeah. What's your best weakness?
Can you expect design challenge? Design Figma? Yeah, just the Figma. Just make something beautiful. That's kind of it. I mean, you can see the one that's on there. So we didn't give him an offer, but I thought it was a pretty solid challenge. You guys have a pay range. If you go on our X account, Twitter, all our jobs are listed there with some pay ranges. But I think those don't make it super clear that these positions are equity, so I can update that later today. Tech reviews, George asking about Axton. Yeah, so, I mean, it's super basic stuff. It's like, do you know anything about computers? You guys cover relocation. Yeah, we can talk about that. How long is a paid micro internship? 2-3 days a week. It's kind of up to you. All right. Should we go on to MLSM?
MLSM. All right. Let's talk about MLSM. So the videos that you see here are all 100% generated, 100% imagined. So these are short rollouts. They're 100% imagined.
These are very short rollouts. Do we have longer rollouts?
Yeah, we do have longer rollouts that I'm going to show in a minute.
Okay.
But these basically are what we run during training of the GPT, the dynamics models. So just as a reminder of what MLSim is, we train our model fully in simulation, in closed loop. So we ask the model to drive in an environment, and then the model learns how to drive using standard supervised learning in that environment, in closed loop. So the model makes mistakes, is exposed to its own mistakes, its own noise, and then learns how to recover from it. And that's how we've been shipping end-to-end lateral and end-to-end longitudinal and openpilot for the past few years.
Why not use a game engine?
I talked about this extensively in my Comic-Con talk last year. A game engine is essentially hard-coded, and then if you want to add scenarios, you need to hard-code scenarios, etc., etc. So you'll be basically writing scenarios for every case that you want to cover, and that's not scalable. You'll be just writing scenarios. You'll be just hard-coding cities and hard-coding roads, which is not really scalable for learning how to drive. And then we also want to not just solve self-driving, but also solve robotics in general, in a general approach. So yeah, game engines have their place. They're good for validation, but they're not, I would say, not scalable for learning how to drive and learning robotics.
I mean, just to add on to one top of what he's saying, machine learning models will do well in situations that they're trained on. Game engines, forget about even other than self-driving. Simulating a road in India and Nigeria is not something that game engines generally focus on, right? If you think about GTA 5, which is an incredible game engine, it simulates California driving. Obviously there's some gamified parts that are not realistic, but even if you think of the whole world of GTA 5, which is a multi-$100-million project to make, you're still only simulating LA driving. This just doesn't scale. You need to use real data for self-driving, and then obviously beyond that, the stuff that Yassine has been doing isn't even limited to driving. It scales to anything. So it's just a much better approach.
Yes. So the new approach now is to actually learn a driving simulator from data. So the simulator takes in previous frames and previous actions and other things that I'm going to talk about later, and then imagines a rollout that's a video of driving. So I'm going to show you an example of one of these rollouts right now. It's a little slow because it runs on my desktop. But yeah, this is one of our newest models. This is fully imagined. The top is the F-cam, the bottom is the E-cam. So this is a very simple scenario. Everything here is imagined using a machine learning simulation based model. So we trained these some time ago. So that's it. Trained some time ago, and now we've been successfully training driving models inside of these simulation environments that are fully learned, which is very exciting, and that's what we're going to drive on today.
So we're talking about getting experimental mode out of experimental. This is exactly all we're working towards.
Yes. So the idea of machine learning simulation is what problems we had with the previous simulation paradigm, which is short, the small offset simulator, which we talked about in previous Comic-Cons too, is that the simulation range is not big enough to learn recoveries, especially in longitudinal. Which is why your models don't drive at the speed that you want on the highway. Sometimes it'll drive too fast, sometimes it'll drive too slow, and they don't recover to a good speed because they don't have enough training range where they accelerate hard enough or they decelerate hard enough. So this will be solved in machine learning simulation because we have essentially infinite rollout deviations.
Are we ready for a drive?
Yes.
All right.
Yeah.
Let's go to the car. We'll stop by fulfillment real quick to remind everybody about the 4th of July sale. Sure.
Yeah.
Thieves on the frame.
What's up, guys? You guys
This is
know
a
about
research patio.
Yeah. This is brand new.
Brand new research patio.
Oh yeah, the research patio was a great project. In January we had a sprint. Everyone in the team had goals, and if we achieved all of them, we were going to get a nice patio. And I mean, everyone was working super hard. I think we were here all at 4 a.m. the night before. Basically, everyone was fighting to get to the deadlines, and we made it. And we got our couch. Now everyone gets to hang out in the sun.
Yeah, we are waiting for some more furniture, I think, but it's going to be beautiful, especially with the summer coming up.
We've still been waiting on, it was a real good time fighting for that goal. We're trying to find another goal for us to work towards. Do you guys have any ideas?
Right.
Attempting to reconnect. All right, reconnected.
All right.
I think we're back live. We're back.
We're back. We're
back.
We're back?
Oh,
yeah.
So lunch.
Oh, here we go. Man, you guys can't smell this, but it looks pretty good.
Hi. You guys are live.
One of the most important parts of the company right there.
Let's go to Circle.
Yeah, we'll go to Circle. But yeah, I was saying we're looking for another thing we want to put on our patio that we can work towards, something like hot tub, sauna. If you guys have any ideas, let us know. There's a...
You can park the boat there.
Huh? Oh yeah.
We'll park the boat there.
The sailboat.
Alright, let's do
Real fast.
a circuit close up. So right here we're building the lightning hart songs we showed off recently. This is some recent insourcing work. And then we can quickly just pan around circuit spoke.
Okay.
Oh, pointed this way?
Yeah, stay in front.
Okay. Alright, so this is what these lightning hearts look like. This is how we can give you guys $150 off. We're continually working to reduce the price of these guys. So we used to buy these, now we build them. We source all these 845s, all these components. We get the best price, and then we pass those savings on to you guys. Right. And then we can give a sneak peek at Harness V3, which will be launching very soon.
Yes, this is the factory.
And then
Hi guys.
show off these
Yeah,
devices being
let's go.
built.
This beautiful stack.
We're doing some super tap soldering, inserting an eSIM for you guys. Look at all these screens we got prepped. You guys think we're dumping Comma.ai stock?
Ready.
Look at all this stuff we got.
Ready.
No new product. Comma 3X forever. Look at all these guys.
Alright, we're people say it's laggy.
Laggy?
Is it still laggy?
Oh, look at all these devices going out. How's it going, guys?
Hi.
Hi.
This is the.
So you buy a Comma 3X today. It'll ship tomorrow. Fulfilled right here. For our awesome fulfillment team.
Can you talk about the sale a little bit?
Yeah. So $150 off for 4th of July. The sale will go on for at least a week. We're not sure how long it'll go for. Really just depends on stock and how many you guys buy. We can turn it around and show them.
Wait, there's so many of them.
Yeah.
They're all ready to go. Are these all going out today?
These are all going out today.
Oh my god.
These are all orders from today.
Crazy.
Yep.
Okay, it's okay right now. It was laggy for a minute,
But
it's
we're all
okay.
good now. Cool.
We're streaming on an iPhone 15 Pro. Is it 15 Pro?
14 Pro, I
14
think.
Pro?
I have the slightly smaller cameras.
This is not sponsored.
Not sponsored. Not
You
sponsored.
guys, it's really not our fault that the streaming is so bad. It's terrible.
I mean, it is our fault to some degree. We take ownership here of
I
all the
just-
products we ship, including this stream.
This is.
But yeah, these are all going out today. This isn't even all of them, right, Ada?
Yes, sir.
Yeah, we got a whole lot going out
we
today.
have another probably 10. We'll
Another
be down
10?
to this.
But look at this. It's crazy that they managed to stay on top of this. There's like 5 million harnesses.
So there's 39 different harness connectors that support our almost 300 unique cars.
Look at this.
This is what you're-
Hyundai is like.
That's half
It's like
of it.
half of it.
We just placed a massive order for Hyundai connectors. Yeah, this is what your Comma 3X looks like right before it gets fulfilled. It's got a nice calibration sticker. We calibrate every screen so they look exactly the same. And then that gets taken off right before it gets boxed up. Then you got your
Nice.
accessories.
So buy your Comma 3X today.
You can try out Secret Good OpenPilot. You buy your device today. You install a Secret Good branch.
I
you all good?
see a question about the car height. I'm gonna talk about that when we're on the drive. We're going on drive right now, guys.
Tiny box
You're-
preview.
You're too impatient. We're going.
Wait, I was reading some of the other questions too.
Anything good?
So much impatience.
Oh, someone suggested a hammock for our patio. Yeah, we thought about a hammock. I think we might do that.
You don't want a hammock.
You
Trust me.
don't want a hammock?
No.
Oh.
As someone who slept in a
How is
hammock.
human driving data? Okay, two questions. We're gonna answer that.
Oh.
I got it.
about that.
High security office.
Really selling quality of the office with the Wi-Fi. No, this is LTE. This is blame T-Mobile.
This is AT&T actually.
Oh.
AT&T.
We got high quality stuff.
No, our Wi-Fi is actually really good. We made it really good so that we can drive the body around with no lag.
All right, let's switch back. How many cars in your fleet? So we've got about 15 cars. This isn't all of them, but this is about half. We're gonna take you guys for a drive in the Corolla today.
Secret good open
Do you
bar.
value challenges over bounties? No, they're valued equally. Bounties are preferred for working on the openpilot team. How many cars got that? Does the new model work on the 3X and not? Everything that works on the 3 and the 3X, it's all the same stuff. 3X is like a refactor product. It's easier for us to build, cheaper for you guys.
Okay, so I saw there was a question about height and another question about how is human data used in the MLSM paradigm. So the ML simulation model, what we call the dynamics model, is trained on human data. And it's very important that we have diverse human data and diverse human paths and human people driving, because that's essentially the brain of the driving is the simulation model. So we do use human driving data to train the simulation model.
I want to prove to them, so they're asking, is this like a secret branch?
This is not a secret branch.
We should click in the settings, we can show them. Let's
you
prove
could-
it to them.
You could do git checkout, secret good open pilot, and then you can,
Whoa. Do you have anything to hide? Why aren't you showing the people?
so what?
Let's show
Oh,
'em.
this?
Let's show 'em.
Oh, I'm driving.
Let's do it before we
Here
get on
you
the road.
There you go.
Secret good open pilot, 20 hertz. I don't know if you guys can see that. It's all stock. Secret good open pilot, 20 hertz.
So we're going on the highway. The other question was about height. So as I said, the simulation model is trained on human driving data, on our human fleets, on our people's cars. So given that people have different heights, cars at different heights, the simulation is aware and is exposed to different heights. So I think that answers whoever's question that was about the height. So we're engaged right now. We're going to do a lane change. As you can see, pretty nice, it's pretty smooth. So this model was trained fully in simulation. Nothing, we're going to do another lane change. Nothing was hard coded. Everything was learned from data. And it's pretty exciting, we think. Very chill.
Yeah, so the first goal is this just has to perform the same as the model that's in release, and then the next goal is making end-to-end long a chill mode feature, and then we get rid of experimental mode.
Exactly. So we're kind of focused now on lateral a little bit. I mean, it's hard to disentangle these two things, but we don't want regressions before we ship this to master soon. So we're going to try to match the performance, which we think is going to happen soon, because we're pretty close right now. And
you want to tell them about our constraint? It has to get shipped soon.
It has to get shipped before October 1st, and then we are technical paper, research paper that describes how we train these models. We're also working on a blog post that's gonna be published soon, yeah. So those are our constraints. Hal, do you have anything to add?
What do I have to add?
Beautiful drive.
Yeah, we're gonna print the weights. Did you mention that?
Oh yeah.
A lot of parallel things going on here.
Yeah, we wanted something cool. You know, if we make our goal, like this is such a long time coming. I joined comma 7 years ago, and this whole goal predates my arrival at comma for a long time. George wrote a paper back in, I think, 2016 talking about this dream of making a simulator, training in that simulator. I think theoretically it was always an obvious idea, but the technology just wasn't there, and it never really succeeded. But we're really at the precipice now of shipping this super long-term dream at a time when other people in the research community are coming around to this. Tesla talks about similar approaches, Wave does. I think people are really seeing this is the right idea, but we're here now driving on it. So this is such a culmination of such a long dream. So we're super excited about that, and then we were trying to find some exciting ways that when we do ship it to users to kind of cement that. We figured, why not print all the weights on paper in an encyclopedia book series, since this is probably the last round of models that you can print. In the future these models will be, if you printed them, they'd be thousands or millions of pages. So this is the last time it's possible, so figured why not. And maybe we'll sell them if anyone wants to buy them.
Alright, we got a lot of good questions, so let's scroll back.
Alright, I'll take
Can we replace NPC2?
Yes. In fact, this model doesn't have any lateral MPC that we're driving on right now. No MPC.
But neither does one in the release.
Well, the one in the release, we moved the MPC kind of in the back end, so it still somewhat exists in the model, has like a block that serves as an MPC block. But this model doesn't have anything else that resembles the MPC, which is really cool. So it's all trained end to end, no hard coding whatsoever. I don't know if this is the right exit actually.
It's pretty cramped back here.
It's a small car.
Alright, let's see what else. Got a lot of good questions. So they want to know, why was it 5 FPS at first?
So currently we're somewhat compute constrained with these models because they take a long time to roll out, the dynamics models, the simulation models. So we trained them in 5 FPS in order to generate longer rollouts and without generating so many frames. So it takes some time to generate one frame, and you can imagine if you want 10 seconds of rollout, you would need a lot more frames at 20 FPS than at 5 FPS. So that's what we did. we trained them at 5 FPS, and we still do. It's just that now we have a trick to be able to use them in inference time. Harold came up with this trick that basically strides the history of the model to be able to be used at any FPS, even if it was trained at 5 FPS.
Steve's got a seatbelt on. There's no custom code here.
Guys,
we're not running a weird branch that isn't public just to not put our seatbelts on.
I love my seatbelts.
Also, it's super inconvenient for us to set up anything that isn't a public branch. So.
Yeah, I can talk about why it's called secret good openpilot.
Oh, they have a question I don't want to forget about first.
Okay.
What happened to nav?
You want to answer that?
Yeah, sure. Nav, we did nav to do Taco Bell. That was kind of the vision of, the whole trifecta of parts, end-to-end lateral, end-to-end longitudinal, and then nav. But when we started writing nav, to get it to work, we ended up writing so many hacks to deal with the fact that the simulation was poor quality, which led to issues around exits that we had to put a lot of effort into fixing. And it became really hard to maintain because there was so much added complexity. And so we just realized that, we have to ship the new simulator before nav will ever be good. And making changes with the whole nav stack in the training stack is really hard. It just adds so many steps to every validation procedure, adds so much infrastructure that needs to be maintained. And we want to deliver, this new architecture as quickly as possible because it's just the best way openpilot will get better. So we removed it, we'll add it back once nav is a majority source of disengagements.
I mean, yeah, you guys saw, everybody was asking about experimental mode and chill mode. They weren't asking about nav for the most part. So that's where most of the value is right now.
I mean, nav is cool, but it was getting in the way of something more important, which is shipping this, which will make the experience better 100% of the time instead of only when using nav. This will make the experience better on highways, on city streets.
All sorts of subtle ways. Yeah. I just drove up to San Francisco and back, and most of my complaints were longitudinal and fairly subtle. It'll make cut-ins really smooth, approaching slower traffic. It'll make all this stuff really good. The same stuff laneless does for you, where you go between intersections. It'll be like that for longitudinal.
So we're engaged right now. We're in experimental mode. We're very excited about these simulation models because essentially it will be in a state where it's unbounded, where it's only data in, retrain the model, make the simulation model bigger and better, make the driving model bigger and better, and look at that, it's keeping it clear. Well, it's not really keeping it clear. It tried. It tried. But yeah, we're very excited about this state where we're not bottlenecked by something. We're not bottlenecked by some imperfect simulation environments that we have to go around and make the model crappy to be able to deliver.
If you get rid of chill mode, speed has to be perfect. Yeah, we're all on the same page about this. The goal is to deliver something that is strictly better. I mean, when have we shipped you guys something that's worse to release?
I'm sure they have some answers to that.
On this one intersection on my commute.
I also want to answer one question. They were talking about liability. Someone asked who is liable. We're making level 2 systems. I think we're extremely transparent about that. Yassine is driving. Yassine is in charge of the safety of the car. This is a driver aid. It makes driving more comfortable and more enjoyable. Safety is in the hands of the driver, and that's not going to change anytime soon.
Look at this, you guys. Isn't this great?
Look at it go.
Good.
So without end-to-end long, you would see this thing where it tries to speed up as it loses the lead. So this automatically slowed down.
And look at how it speed up for the highway. It's beautiful. There's some cars next to me, so I have to.
Can we still have nav back as a toggle option? No, so that's the whole point, right? It being in release and an openpilot master means we have to guarantee some quality around it. And there is some friction to improving all this other core functionality we want to ship, which is why it's removed, but it will come back. Let's say people are calling Prime now with no nav. It's for dashcam features. Solving self-driving. I mean, these things they're not related, right? We're very serious about solving self-driving, but we're not looking to ship you a robotaxi service. We want to solve the problem, and then we're going to move on to more general robotics.
People talk about this liability stuff and why are you trying to solve self-driving cars but not dealing with that we're 3 engineers. This company is almost exclusively engineers. We're only interested in building technical solutions. Along the way, we want to ship you useful products, but we have zero interest in building a legal team to be able to take liability and find areas in which it's reliable enough, or like have an insurance policy. This stuff just does not interest us. We're an engineering team. We make engineering solutions, and we try to sell you products that are useful and don't have any implications on safety that you have to worry about. It's just the driver aid. That's what we do.
No more stopping at the red. No. So it still does that. That had nothing to do with nav. That's all end-to-end longitudinal.
So there was a question on Twitter I saw last night about how we use these dynamics models, the simulation models, to train policies. So what we came up with is this architecture that not only predicts a video, not only simulates a video, but also simulates a trajectory. And we use that trajectory essentially to train the policy model that is driving the car right now. So the dynamics model, the simulation model, is both a video simulation model but also a trajectory simulation model. And we use we use this model as some kind of a teacher to train a smaller model that runs on the car. But we will write a blog. We're currently writing a blog post about this. It's going to be very detailed, and we're going to talk about how this works in detail. And we are also going to write a research paper when this is shipped. Very exciting.
So there's also a lot of questions about whether this is vision only. So what we're driving on right now is the end-to-end models are all vision only, but there is still a policy that if the lead is very close, is basically the most aggressive setting of stock openpilot, that radar lead policy is still there as a stopgap, but everything related to what the model outputs is end-to-end. And as you can see, in these drives when there's no lead and stuff, like nothing dramatic happens as it switches over to vision policy, because the vision only actually works pretty well. So yeah, we're hoping to ship this on radar-less cars as well. Expect that to go fine once these models are pretty good.
It's very nice.
How much does performance degrade with high speed?
What do you mean degrade at high speed? It doesn't generally. What's the high speed?
I don't know.
Yeah, I don't know. It's generally
performance is not really dependent on speed. In general, actually, most cars just offer you lower torque at low speeds, but that's a car limitation. Nothing to do with openpilot. Guy keeps asking about V-slam. I don't know if that's a particular slam or if it's just slam in general.
I don't know, vision slam. I don't know.
He keeps asking that we should mention
slam. No, everything's learned. We learn things. Everything's learned from data.
We're lazy. We like to just learn it from data.
Yeah, we have a localization algorithm that is a prerequisite for a lot of this stuff. It's relatively classical. It's called MSCKF. We've talked about it a lot before. That stuff hasn't changed in years. That's something we wrote like 5 years ago and has been incredibly stable. There really isn't anything better out there. So I don't know. That stuff's all classical, but it's only used for localization. We don't actually do SLAM. It's just localization.
Oh, Harold, I got a good question for you. Will the car take advantage of engine brake and coasting region?
Oh yeah, that's something we recently came up with that I've been very passionate about. So we were thinking about what is the right API for the policy to communicate with the car. And for lateral, we just have curvature, right, which is just the angle of the turn. And so for longitudinal, acceleration has this problem that it doesn't capture when you want to coast, when you want to brake. People get very annoyed when you press the brakes when a human wouldn't. So I think the right idea for the API is you tell it when you want to stop, you tell it when you want to press the gas, when you want to press the brake, and then how much you want to accelerate and decelerate. And so we're working on that now, and we're trying to ship that soon. So the model will decide this is an appropriate time to press the brakes, this is an appropriate time to press the gas pedal, and so then that should enable coasting behavior. And we want to ship that directly to master.
Someone is asking about red lights. Red lights still work. We're going to approach one right now.
This is a end-to-end red light.
Hey, you notice how it stopped for that car that was cutting into our lane?
And it's going for the green end-to-end. Nowhere in the code base is talk about traffic lights.
Describe the future of experimental mode. It will not be experimental mode. That's the future. So we will not be shipping any more models to openpilot master that are not trained in this new simulator. We're committed to the future. We want that to be October, but if it goes beyond that, we're not going to compromise the future of openpilot to ship you some incrementally improved models. What is the size of the current install base? So we have about 5,000 daily actives, and then quite a few more weekly and monthly actives. How do you learn inside of the ML simulation? I mean, we kind of talked about this.
So we talked about it. The ML simulation is not only generating frames, but it also generates trajectories and what we call a plan. We use that plan to learn a policy model, a student model inside of the simulation. Basically, that's how it works.
You want to do a little bit of city driving?
I'll say it right.
We can do a stop sign right here.
Is there a stop sign here?
Yeah, right up ahead.
Oh.
Yeah, see, even Yassine couldn't see it, but because this is end-to-end, the model isn't driving too fast. It knows it maybe should expect a stop sign coming up, just like you would. If I order now in October, there will be an update. We hope October. You know, this is.
I didn't see it.
Yeah, I didn't see it. All right. But yeah, in like a conventional ACC system, this would have just gone straight to your max speed of like 65, 70 miles an hour. So it's always doing something that's like somewhat in distribution for what you're. It's not doing something that's like totally crazy for the situation.
Yeah.
But yeah, October is the goal. But this is very bleeding edge stuff. This is something very, very new.
I did see a stop sign.
Okay, yeah, I saw this one. That's good. What data do you use to train the model? Data from our users.
Stops for the pedestrian. Look at that, beautiful.
Yeah, we only use stock OpenPilot. This is like, you know, if you have a jailbroken iPhone, Apple doesn't look at your crash statistics or anything. They don't care. Given a car with sufficiently good steering torque, what is the main limiting factor on getting parity with? Yeah, we first have to ship this new ML simulator, and then we can do a whole lot more things. Like our old simulator just really didn't support doing turns.
Yeah, so the idea is to when we ship this, we need to scale this up, scale the simulator up, scale the policy up, scale the data set up, and I think when we do all these things correctly, we will have incredible performance on a highway, on city streets, on parkways. So yeah, given sufficient torque, it should be able to do turns pretty well. It already seems like the turns are significantly better on this model. But yeah, what's needed is scaling up the models.
Someone asked about, do we benchmark against FSD? No. Again, we have a problem we're trying to solve. If FSD was really great and then the next ray sucks, this has, like, there's no counterfactual here, right? It's the exact same scenario. We're moving as fast as we can. You know, we just have some very real engineering problems to tackle, and this takes time. We're very honest about the problems we solve, and this is largely the appeal of working here. So if you like just solving problems, it's probably a good fit. Using OSM data to predict. No, you don't use mapping data when you're driving, right? Your map doesn't tell you, like, hey, there's a stop sign up ahead, be careful.
Any interesting questions?
Does that mean there's some kind of new hardware coming out? No, this is a comma 3x, guys. Stock comma 3x. Comma 3 is exact same as a 3x. Pedestrian deal, yes. Pedestrian and obstructive detection will all be end-to-end. We have very little interest in doing anything that isn't end-to-end.
We can head back to the patio and do the final Q&A.
Yeah, let's do it.
All right.
Maybe we want to go inside. Let's see how it is.
We can see. Yeah, I don't know. I keep getting distracted by the phone trying to check for questions. But there's a couple more things that I want to mention about Secret Good OpenPilot. Do when we're upstairs.
Somebody's asking about high school internships. If you could do our challenges, this is literally the definition of what we look for.
Yeah, we do not discriminate on age, on
There's
race,
been a couple
on
people
anything.
we can't hire due to, like, you know, we couldn't hire somebody from Russia or something one time, or North Korea.
Yeah, even on immigration, we do absolutely everything that we can. You know, sometimes there's impossible things, but most of the time we do whatever we can. Yeah, what I wanted to mention about Secret Good openpilot, the reason it's called Secret Good openpilot is for a long time there was this meme in the community that we were testing out branches that were so much better, and like we were just not, I don't know, telling people about it or something. But
no, the problem with the mic is.
Oh, the mic's over there. We're gonna flip the mic for a second. Just a minute. There you go. Just want to read your questions. Oh, watch out. You're touching the screen. Okay.
But yeah, the reality is that everything that we've driven on over the last like 5 years has been a publicly available branch. So that's why we called it that. There is no secrets. Everything we've tested, you guys have had access to. We don't really, want to keep things internal. A lot of times it's just not interesting. There's nothing really for interesting to see. But just so you guys know, if you want to see what we're up to, if it's not in a public branch, it means we're not driving on it. So that's kind of always a good benchmark of what we're doing. Let's see what else is there.
So I don't know why there's still ambiguity around solving self-driving cars. We want like a very general solution to solving self-driving cars. We want to build an agent essentially. We describe this pretty well in the Talk About blog post. I'd recommend reading that if you haven't. And Harold's blog post from like 4 years ago or something.
Yeah.
But yeah, we want to ship some software that can drive you most of the time. It clearly doesn't do that right now. Other than that, we, robotaxis, anything else, we want to ship you a comma body in your house after that. That's the real thing we want to ship you. In the meantime, we'll ship you little devices to put in your car. We need better documentation. We're working on that right now. There's a good bounty out. We're going to just copy the rerun documents because I really like them. We're working on like exposing a good roadmap for the things the community can work on. The bounties, I think, have been very successful in kind of exposing what's important for us to work on right now. Are you guys planning on incorporating text into the text?
No, we're not planning to do that. We're trying to do things end to end. If by text you mean text from the road signs, we're not planning to do that. We're not planning to do a ChatGPT either. So no, we're not interested in that kind of explanation, quote explanation, quote models. So no, end to end image from video from photons from photons to acceleration and steering from video. Yes.
Not quite photons. Yeah, we're working on some like pretty major refactors to the car stuff. I would expect in about 2 months this stuff to be in like a completely different state. Essentially the goal is to pull all the car interfacing code out into its own repo, and its whole job is to be like a Python API for your car, and that is a repo that can be very much finished for a lot of cars. The architecture will be very simple. Then you don't have to understand anything about how openpilot works. We'll have some really great docs. I would say in about 2 months that should be in like a very, very good state.
Question about if we need engineer. Yeah, if comma.ai/jobs, look at the challenges. If you're interested, check them out. If you think you're a good fit, welcome to try it out.
No, so that's the cool thing. We don't need to be open to it. You can just sell it. It'll work with, have a fork or pretend to be another car and it just works with stock openpilot. That's up to you if you want to make something like that. We have no interest in these cars that just don't work. There's enough of them where we support 300 cars right now that are like a pretty good openpilot experience. And a good fraction of those, like all the modern Hyundais and Toyotas, are very, very capable and can do the Taco Bell drive. So it's enough cars where we don't need things like the comma pedal, the SDSU. We don't care about bringing every car along for the full openpilot experience. We don't care about that at all.
So there's a question about how the model recognizes a stoplight from a distance. The model actually, inside of the model, there is some recognition. So the model understands where the stoplight is. It doesn't do that explicitly. It is just trained to mimic, to do as what human drivers do. So how would you recognize a stoplight? Well, you see the stoplight. And then when you see the stoplight, you try to slow down, and that's what the model is trained to do. And then internally, obviously, it learns what a stoplight is and what a stop sign is and all those things. But yeah, it just tries to mimic human driving data. No hard coding of stoplights and stop signs. size of the model that we use today. Same size as before. I don't have it on top of my head. The simulator, I know exactly how many parameters. It's about 400 million parameters. It's a smallish model. We're planning to make it bigger soon.
Yeah, I mean, this stuff will all get better. Right now, I mean, we should show them how crappy TinySim is for longitudinal.
Okay. There's a question that it doesn't slow down until it sees the red light. I mean, you have to see it to slow down, right?
Shouldn't be part of your vocabulary. We're very honest about what our priorities are. It's open source. People can build off what we do. It's very important to us that people can do that. But, you know, we're not like media trained. The most professional thing we've done is, you know, we got a camera rig so we can have a stable video. Otherwise, it's very like raw and it's a very raw look into how things work here.
Yeah, people are asking what should we expect by October. I mean, our goal is just to ship the new architecture and to not have any regressions. The first priority is that. After that, it will improve quickly, but we just really need to move to the new architecture. I mean, the real power of this architecture is that we're not hand coding anything. You know, it's basically only Yassine working on the simulation models, and even Yassine is not writing anything that is particular to driving. Like, we're just writing generic machine learning solutions, and they just happen to solve these problems pretty well. So moving to that is so powerful. We don't have anything hand-coded about cars, about lane lines, anything like that, which we did to some extent before with our previous simulation strategy. We had, you know, assumptions about roads, we had assumptions about the distance of cars, all that sort of stuff. But so all of that is gone now, and so if we can ship that without regressions, that sets us up really well for improvement soon.
You don't say that to customers. It's okay.
Okay, let's not argue.
Let's say his username.
There is a question about comma shipping a small training example. Yes, we can do that when we have time. We actually did that for some examples, like comma VQ is a small data set where you can train a model. Comma 2K19 is also a small data set where you can train models. The steering data set is also a small data set. So we do have some open data sets where you can actually train models to experiment with and then come up with interesting ideas that we can then, if we like them and if they look promising, we can scale them up and use them in our training stack.
How many new versions? I mean, it's not like we have a roadmap for this or anything. As many as we can ship to it. I mean, we showed you guys the openpilot fleet right now, the official fleet. Did you see any other hardware in there? Comma 3Xs will be around for a long, long time.
MLSM train on fork data. I'd like to contribute. Well, fork data, yeah, it really depends. The problem with forks is that they alter our logging infrastructure, so we can't really parse their data.
It's like using you wouldn't take a jailbroken iPhone to the Genius Bar. It's the same thing.
Yeah. We would like to, but it's hard to do. We're gonna try to have a bigger presence in Europe. We sell internationally.
How many users in Europe? Probably like 1,000, maybe 500.
Some questions about external GPUs. That will probably come soon when we ship these MLSim models, and then we scale them up and scale the driving models as well. When that happens, I'm assuming in the next year or two, we will start needing bigger GPUs. Ever try out MATLAB to train deep learning models? No.
Anybody buy a 3X yet with the sale? Anybody want to try out Secret Good OpenPilot? Credit, the best forks. I mean, yeah, the forks are great. Sunny pushes a lot of stuff upstream. Forks are great inspiration for us. So, I mean, these new models will improve the thing for every car. It's not really specific to any given car.
Someone bought with the sale.
Nice.
Mitchell. Yes. GG.
Oh, we can pick one random person who buys and then show. We can. We'll post our segment in Discord.
Thanks, Grant.
What kind of timelines do you guys want? We don't really have timelines.
Well, we've kept saying October. That's the only timeline that matters.
Yes.
for the free hat announcement.
I think we're running out of questions here.
Yes.
Oh yeah, I probably won't work with your 2011 Nissan.
What will a new ML engineer hire to be tasked to do on Litter today? Yeah, so work on the machine learning infrastructure, the machine learning training code. It really is, as Harold said, it's pretty standard. It's very agnostic to driving or to anything. In fact, we kind of ported our simulation stack, our simulation solution to the body, to the comma body, and it just worked, and it was doing loops around the office really nicely. So yeah, it's standard machine learning, learning diffusion models, learning GPTs, training, policy models, writing machine learning code.
Infrastructure.
Yeah, so just 99% or 95% of what we do in our team is infrastructure and testing work. It's fun to think about machine learning architectures and dropout and batch norm and all that stuff, but realistically, the hard work is making sure that the GPUs are running stably, that the machine's not crashing, that it's easy to start training jobs, it's easy to stop training jobs, that it's easy to track training jobs, and actually knowing how well the models perform. That's 95% of what we do. Yassine works more than anyone else on these actual models, and even his time is spent majority on infrastructure and all that stuff. That's just the reality of machine learning. Having stable tools and having good infrastructure is the only way to make things work, and that it's what everyone in our team does.
Yeah, and outside of our team too, you can see in most research labs, we don't want to be in a state where it takes you a week or two to set up an experiment. You want to make your experimentation environment easy. You want to make your testing easy. You train a new model. Now, so what? How do you know if it's better or not? You need to write good tests. You need to trust your tests. You need to make them fast. You need to make them run in the loop. You need to make your training fast. So, yeah, a lot of infrastructure. And it's fun.
There's a good question about... do you guys feel constrained by hardware at all?
No,
not yet.
It's worth trying in that it's really cool, that it performs very similarly. If you're not going to have fun with that, then it's probably not worth trying right now. But it is a massive milestone that you can have a green connect timeline with no overrides. That is a huge milestone we've been working towards for a year and a half.
Yeah.
There's another question about depth. Do we use depth? With these MLSM models, we do not use depth anymore. Depth is learned end to end by the GPT.
Somebody asked about lightning hard reliability. So that's the new SOM we started shipping about a month ago. So we've shipped many hundreds. Not a single one has come back yet. Comma 3Xs are incredibly reliable. Any plan for Mercedes? Again, we don't really have plans for cars. Our next car, though, will be a Lexus ES. That is our new demo car. If anybody's got any thoughts on that, what model year we should get, what trim or something, if anybody's got tips, post them in Discord.
There was a question about using disengagement signals to train the model. We do not do that yet, but we are planning to do that after we ship these models.
We can talk a little about model testing.
Oh yeah, the testing. Yeah, we do use them for testing and for the disengagement analysis.
No, they're just talking in general. How do you we train a new model. How do you know it's good?
Well, we have a whole suite of tests. We have many metrics that run on a test set of about 2,000 minutes of driving. We have, so these are off policy tests, on policy tests as well, on real data using a simulator, and also using a classical simulator. We have some unit tests. The classical simulator that we use is now MetaDrive. We have a list of unit tests that we use to basically see if there's anything clearly broken in the model. But the performance is monitored using real data and off and on policy driving on about 2,000 minutes of driving. These tests run in the loop while we train, and then we can see if our metrics go down, go up, go down, and that's it.
Yeah, so they're like end-to-end tests that test very specific units of driving. What is the benefit of upgrading from C3 to C3X? It's probably not worth the upgrade. It's more for new users, get a cheaper device. It's a little more reliable. The sounds are a lot better. So Harold was very passionate and drove that. That's probably the biggest difference.
So there are someone asked if these tests are in the openpilot repository. Not the tests that I talked about, but there are other tests in the openpilot repository, and I know that they're working on the MetaDrive loop.
We got a cool thing. So yeah, openpilot now has a test as of maybe a month ago. Shout out to Bong Bui who wrote that. That drives a loop in MetaDrive. So it spins up the whole openpilot stack, drives a loop, and ensures that nothing is critically broken in openpilot. That could be like the params learner, the localizer, the model running, the driving model itself. So that is a super, super cool end-to-end test for the whole stack. What we want to do now is get that posted in every PR. We'll post the what the UI would have looked like. Imagine you had your comma 3x driving there. It'll just be that same UI, and it'll be posted as a comment to your PR. We got a bunch of cool ideas like that will be rolling out soon. Maxime didn't show up here, but he just started. He was an OpenPilot intern for the last couple summers. He's very excited about making the OpenPilot development experience super fun for you guys. Is data connection required? Nope, all local.
Someone keeps asking about DCAM, blind spot monitoring, and not just lane change. It's just so not in line with the critical improvements that we're working on. We're not against that sort of stuff, but we have way more important stuff to worry about right now. We want to ship these new architecture of models as soon as possible, and then we're going to work on improving the longitudinal performance. The biggest priority that we want to fix is we want you to engage on experimental mode on the highway and have a better time than you would without it. That is by far our biggest priority, and to whatever extent we can, we put all of our effort into.
Yes. And then when we're done with that, we'll move to the things that you just asked about, like the DCAM or nav, things like that.
Yeah, harnesses are currently handmade, and the connectors are extremely expensive. We're working on fixing that right now, actually. Been running in the UK. I'm only got the road. That's a long secret. Thanks. Yeah, it's pretty cool. It's like a new power, right? It's a completely different way to drive.
All right, I think we're
Yeah,
kind of
that's it.
cycling through the questions now.
No, we're not going to do an 8-8 event. I think we'll take one more good question, and we'll call it a day.
Last question, you guys.
Also, if you join the Discord, there's a special code that gets you a free hat with your $150 off a comma 3x.
Anything new about the comma data center? Well, there's some exciting things. Yes, we're trying to expand it to be able to train bigger models and to use these new bigger dynamics models. So yeah, very excited about the new comma, not a data center,
Compute cluster.
compute cluster.
All right, cool. Let's call it a day then. So, reminder about July 4th sale. That's just while supplies last. They're flying off the shelves right now. You guys saw fulfillment. And then we're hiring. If you want to help build the future of OpenPilot, there's lots of good work to still be doing. So, super simple hiring process, challenge, couple phone calls, and then it's paid on-site work. And it's like a mutual thing. You get to see if you like working here. It's a pretty cool thing.
Yes.
Yeah, maybe in Discord. Yeah, if you haven't joined Discord recently too, we did some pretty big refactors. So if you want to just play around with OpenPilot and stuff, we're working really hard on this. There's some now really great development channels. We deleted our dev OpenPilot internal Slack channel, so it's all public on Discord now. Yeah.
And you guys, we're super excited about MLSM driving. I hope you all are. This is really the future of OpenPilot, the future of robotics, and we're really excited to deliver on this as soon as possible.
We're going to be the first. You'll see. No, we'll be the first to ship.
All right.
All right, see you
guys.
guys.
Thanks for
Bye.
the-